Welcome guys sa second episode ng Solve Natin Yan, JP Academia. So sa second video na to, so again Taglish to, Tagalog, English, and we will solve problems related sa kinematics. Okay? And we have the following problems na isa-solve natin for this short video. So first may problem ako regarding average speed, then constant acceleration, one dimension, mga translational motion lang. Then free fall, may dalawang problems ako. Projectile motion, may dalawang problems din ako. Acceleration vector, ito yung pinagkaiba or yung importance ng parallel and perpendicular component ng acceleration vector. Then we have uniform circular motion problem. Yung last ay relative motion problem. So let's start. Okay, so for the first problem, for average speed, Mary drives for 4 hours at 50 kilometers per hour and for 4 hours at 40 kilometers per hour. What is her average speed? So kung maalala natin yung formula natin ng average speed, so ito yon. So total distance lang yan. Then divide mo ng total time. So we have, kasi it's a given, binigyan tayo ng ng speed, which is 50 kilometers per hour, then 40 kilometers per hour, then binigay din yung time. So may duration tayo. So 4 hours, then 4 hours lang din. So sa taas ng fraction na to, yung total distance, para makuha mo yan, multiply mo lang yung time na binigay, so 4 hours sa 50 kilometers per hour, then itong 4 hours pa rin, sa 40 kilometers per hour. Pag minultiply mo yan dalawa, makakuha ka ng distance over sa total time elapsed. So sa case na to, 4 hours, then another 4 hours, add mo lang, then you will get 8 hours, of course, in total. And you will get this answer for the average speed, which is equal to 45 kilometers per hour. Okay? So next, letter B, Mary drives 200 kilometers at 50 kilometers per hour and 200 kilometers at 40 kilometers per hour. What is her average speed for this trip? So ngayon, binigay pa rin yung speed na 50 at 40, pero imbes na time yung ibigay, ang binigay yung distance na 200 kilometers parehas. Using the same definition ng average speed na total distance over total time, we can get the average speed using the following quantities. So yung 200 kilometers lang, to get the total distance, add mo lang yan. So you have 400 kilometers over, kailangan natin ng time. So 200 kilometers over, yung binigay na speed, so 50 kilometers per hour lang yan. Then, of course, you will get time here. Makakuha ka rin ng time dito. You will get the total time. And therefore, sa case na to, makakuha ka ng 44.4 kilometers per hour. Okay? So, kung makikita natin, mas mataas yung nakuha natin sa letter A kung ikukumpara natin sa nakuha natin sa letter B. Okay? So, next problem. Okay, so next problem, constant acceleration, one dimension. And ito yung problem. A ball starts from rest with a constant acceleration of 5 meters per second squared. So binigyan na tayo kaagad dyan ng acceleration value. And constant acceleration problem naman to. So madali na lang, given na binigay yan. So this is along a straight track. And first, calculate the speed at the end of 10 seconds. So that's letter A. Gusto natin malaman yung final speed niya given this time, given this A, which is your acceleration. Letter B, the average speed for the 10 seconds interval. Then letter C, the distance traveled in the 10 seconds na binigay. So first, i-assume natin na along the positive x direction to. And we have the following given bago tayo pumunta sa letter A. So 0 sa initial speed mo. So 0 meters per second. Then for the time, we have 10 seconds. For the acceleration, we have 5 meters per second nga. So for letter A, we can use this formula to calculate the final speed of this ball given this acceleration and this time. And alam natin na si initial speed mo for this case ay 0. So therefore, you will get the value of 50 meters per second for the speed at the end of 10 seconds. Okay, very simple. Itong formula na to, magagamit na gamit to kapag, of course, constant si acceleration, given si acceleration, and alam mo yung time, binigay yung time. Okay? Then another formula tayo later na kapag walang time, pero binigyan ka ng, let's say, ng displacement or ng position niya, may another formula for the final velocity, pero later na yon. So letter D, this is for the average speed for the 10 seconds interval. What we can do is to divide the sum. So di-divide mo lang by 2 yung sum ng initial speed mo with your final speed. Then you will get this value of 25 meters per second. Okay? But please take note that this is only applicable for constant acceleration problems. Okay? For letter C, we have this position equation x. So x is equal to x naught, the initial position or the initial distance or position, plus vi sub xt plus 1 half e sub x t squared. So alam natin, so i-assume natin na nag-start siya sa origin, so 0 si x naught mo. Then si initial speed mo for this case ay 0 din. That's one of our assumptions. Then we have 1 half, then constant acceleration which is 5, then we have your time, 10 seconds, and you will get the distance of 250 meters. Another method to get your distance is to use this formula. Given your average speed, multiply that with your time t, makakuha ka ng na 250 meters din. Okay, so puntahan natin tong problem na to for free fall. Ito yung unang problem. A coin is dropped from the top of the Tokyo Tower. So, naghulog ka ng coin and falls freely from rest. So, given na from rest ay nakalagay na dito. So, ibig sabihin, yung ating initial speed for this case ay 0. Okay? What are the coin's position and velocity after these times? So, 1 second, 3 seconds, and 5 seconds. Okay? So let's start with this one. So may illustration ako rito. Given na free fall to, so we know that your AY is negative G or it's just negative 9.8 meters per second squared. So at time t is equal to 0, so sabi nga natin at rest siya, so your V naught is equal to 0 for this case. Then yung time mo at 1 second, yeah, this is the time. So, kailangan natin mahanap yung position niya and yung velocity rin niya. Same thing for 3 seconds and for 5 seconds. Okay? So, paano natin mahanap yan? So, mag-start muna tayo sa formula na to. So, familiar tayo rito. Itong quadratic equation na to. So, along the y lang naman yan. Kapag pataas ang motion, that's positive. Okay? So, y sub naught here is the initial position of the object. So for this case, the coin. Then we have v naught y, the initial speed. Then we have the acceleration dito. Okay? So for the y component dito ng ating velocity for this case, so 0 yan initially at t is equal to 0. Then y not dito ay 0 din kasi i-assume natin na mag-start siya sa origin. So we only have this term for this equation, yung 1 half negative g t squared, and therefore you will get vy na ganito, or I should say y. So y is equal to negative 4.9 meters per second squared times t squared. Okay? So ito expression natin for the position. So, paano sa velocity? For the velocity, we have this expression. And we know na initially, 0 naman si V naught Y mo. And therefore, we have this expression for the final velocity for a given time, t. So, madali na lang. Substitute mo na lang si 1 second, 3 seconds, and 5 seconds dito. And you will get the following values. Okay? for 1 second, 3 seconds, and 5 seconds. And yes, that's it for this problem. I think it's quite easy. Okay, so for the next problem, this is still for free fall, the second problem. A ball is thrown straight upward and it rises to a height of 20 meters. Okay, so binigyan tayo ng height na 20 meters. With what speed was it thrown? So, yun yung tanong sa problem na to. So, first thing, pwede nating i-drawing yung problem para na ma-imagine natin. So, ganito yan. Nagbato ka ng bola pataas. Then, of course, alam natin na may negative g tayo na acceleration due to gravity. And alam din natin na kapag naabot mo yung peak height na let's say h, instantaneously titigil yung ball mo and therefore the velocity at that instant is equal to 0. Okay? And we have this given a y na height. So y is equal to 20 meters. Then of course we have your acceleration which is negative 9.8 meters per second squared. Okay, so given this quantities or values, we can use this formula to calculate the velocity or the speed for that was initially given to the ball, given na alam natin na si final speed dito ay equal lang sa 0 at peak height. Then alam din natin yung peak height natin which is 20 meters lang above. And of course, we know our A na constant lang, constant acceleration, which is negative g. And therefore, manipulating this equation, so medyo algebra lang yan, you will get this final value of VIY or the speed which is equal to 20 meters per second. Okay, so medyo madali lang naman yung problem na to and straightforward siya. Okay, so punta naman tayo sa problem natin for projectile motion. Okay, so a tennis ball was released at speed of v naught is equal to 30 meters per second. So meron tayong speed at an angle of theta is equal to 49.2 degrees. So along the horizontal yan. So we have the following. Letter A, calculate the position of the ball and velocity. So velocity, so magnitude and direction yan at 2 seconds. So that's the first thing. Then letter B, calculate the time when the ball reaches the highest point of its flight. So pag na-reach mo na yung peak height, we want to find the time. And of course, the height din. Gusto natin malaman yung height h or y. Then letter C, calculate the horizontal range r ng projectile motion problem na to. So that's the distance along the x or along the horizontal. So try natin i-drawing muna yung problem para mas ma-imagine lang natin. So we have here the x and y axis. Then yung color blue, ito yung pinaka-projectile path natin. Then we have your v naught here. Then we have here your theta with respect to the positive x-axis. Then yung first problem, yung letter A, gusto natin malaman to. Yung x and y na to. And pati yung velocity na rin, that includes the magnitude and direction at 2 seconds. Then yung next dito, gusto natin malaman yung height h, then kailangan niya makuha yung peak height na yon at time t. So in last, of course, yung range nga na to, yung r. So we have the following assumptions. So we will ignore the air resistance para lang sumimple yung problem. Then i-assume natin na magka-start siya sa ground level. So y naught is equal to 0 for this case. Okay? So for letter A, ang pwede natin gawin muna ay get the components of the v naught here. So for the horizontal component, we have 19.6 meters per second. So madali lang kasi binigyan naman tayo ng theta and the magnitude niya which is the speed 30 meters per second. Same with your y component, ganun lang din, and we will have 22.7 meters per second. Okay, pero hindi pa doon natatapos yun, of course, kasi components pa lang yun eh. Gagamitin natin components na yun, mainly to get the x and the y positions. Okay? So to get the x position, this one, the x, kailangan natin dito ay yung x component ng ating velocity. So 19.6 times 2, we will have this value, 39.2 meters. Then for the y position, gagamitin lang natin yung equation natin for constant acceleration with the assumption na yung y naught mo is equal to 0 niya kasi nasa origin yung ball natin or tennis ball for this case. And therefore, meron lang tayo, of course, the y component of your velocity times 2 minus 1 half gt squared. 2 seconds lang naman yan. And therefore, you will have the value of y na 25.8 meters. Okay, so alam na natin si x and alam na natin si y. Nakuha rin natin yung components ni velocity natin for this case. And to get the magnitude of the velocity and the direction, alam na natin yung kanyang x and y components. And therefore, we can calculate the velocity sa time na yon, which is 2 seconds. Madali na lang yun. We can, for the x-axis, that is equal to v naught x. Kasi walang acceleration along the horizontal. A sub x is equal to 0. Remember that na kapag ang pinag-uusapan ay tawag dito projectile motion problem, si A sub x mo, yung acceleration along the horizontal ay 0. So yung acceleration natin ay purely along the vertical, which is your negative g. So for your v sub y here, yung final velocity given the time 2 seconds, makukuha natin yon, which is 3.1 meters per second. Okay? And madali na lang makuha si magnitude. Gamitin mo lang itong formula na to. Then you will have the magnitude of 19.8 meters per second. Okay? May point dapat yan. Or 198. Or hindi, 19.8 yan. Meters per second. Then, to get the angle, madali lang din. Use your tangent inverse. You know your v sub y and v sub x. You will have 9 degrees for this velocity. Okay, so that's for letter A. Then for letter B, we want to calculate, of course, the time na ma-reach mo yung peak height. And alam natin sa peak height, si v sub y mo is equal lang sa 0. Okay, instantaneously, magsa-stop siya doon. And therefore, we can get the expression for your t-peak o yung time mo para makarating sa height na yon, which is equal to this one. So v naught y over g. So yung initial velocity mo na vertical component or y component over g. So this is equal to 22.7 meters per second over 9.80 meters per second squared. And this is equal to 2.32 seconds. Okay? So yun yung time para ma-reach mo yung peak height. Ngayon, to calculate the h or yung highest peak na yun, madali lang din. Ang gagawin mo lang, kunin mo lang yung expression natin for the position or distance, y, with the assumption na yung y naught natin ay 0 niya at the start. So, alam na natin si t-peak mo, isa-substitute mo lang yun yung t-peak na yun dito sa equation na to. And therefore, alam mo naman si v naught y, and alam mo naman si g, makukuha mo yung height h, which is equal to 26.3 meters. Okay, so that's the answer for letter B. Okay, so now sagot na natin yung letter C. So calculate the horizontal distance. So yung distance na to, pinapakita sa illustration, yung letter R na yan. So from this point up to this point. So para makuha yun, pwede tayo magsimula sa equation na to, which is the equation for the position or the distance y. We know na yung y naught natin ay 0 dahil nga nasa origin tayo nag-start. And given na gusto natin malaman yung time kung kailan babalik siya doon sa y is equal to 0. Kasi lumilipad yan di ba? So, nag-increasing y mo, then magdi-decreasing y mo hanggang sa bumalik siya sa 0. Ibig sabihin, may dalawang points in time, sa time, na pupunta siya sa y is equal to 0. Yung una, dito, yung nasa origin siya, yung bago siya mag-start, mag-projectile. Yung pangalawa, pag bumalik na siya doon sa ground level na y is equal to 0. So therefore, we have this quadratic equation and makakuha tayo ng dalawang roots dito. Okay? So tingnan natin yung form nito. So we will have this expression and therefore, yung unang value ng time dito by getting the roots of this equation. So we have t is equal to 0. So that's yun yung time kung saan nag-start siya bago siya mag-projectile. So that's time is equal to 0 second. And yung pangalawang root na nakuha natin, so ito, we will have this expression t sub 2 is equal to 2 v naught y, yung y component ni v natin, over g. Then we will have this value of 4.63 seconds. So ito yung time na ma-reach mo ulit yung y is equal to 0 pagkabagsak mo sa paglipad mo from projectile. Ngayon, dahil alam na natin yung time para ma-reach nga yung buong range r na yun, what we can do is to use this expression. So multiply mo lang si x component ng velocity mo times mo yung time na nakuha natin, which is 4.63, and therefore we will have this range, which is 90.7 meters. Okay, so that's it for this projectile problem. Okay, so start tayo sa next problem. This is for projectile motion pa rin. So Venti, the Animo archer, is standing on a cliff 52 meters above the level field. So 52 meters above the ground. Below shoots an arrow at an angle 20 degrees above the horizontal with a speed of 80 meters per second. So how far from the cliff base will the arrow land? So ito yung problem natin. So first thing, para mas madali natin ma-imagine yung problem, try natin illustrate or i-draw yung problem. So this is 20, let's say nasa cliff siya, then shoot siya ng arrow. So 80 meters per second, 20 degrees above the horizontal. Then given this initial y naught natin, which is 52 meters, we want to find this x. Okay? So ayan, may mga given tayo. And we can proceed first with these two formulas here na nasa right. So yung una, the position equation for the y, given na alam natin si y naught natin, alam din naman natin si v natin, si v naught y specifically kasi may angle naman tayo, then may magnitude tayo, so makukuha natin yan. And we know the acceleration along the vertical is your g lang, which is 9.80 meters per second squared. Now, for the x, we know that a sub x, or the acceleration along the horizontal, is equal to 0. And therefore, we have this expression for the x. At the same time, we assume na si x naught mo ay 0 din kasi nasa origin siya nag-start with respect to x. And what we can do first is to make y is equal to 0 kasi gusto natin malaman yung time na babalik siya doon sa y is equal to 0 or sa point na nasa ground level na siya. So kapag bumalik na siya dito. Okay? And we have this quadratic equation. So simplify mo muna, then you can use your quadratic formula to calculate for the time. So dalawang time yung maka-calculate mo rito, of course. Yung una, you will have your t is equal to 7.08 seconds. Positive yan. Then we have your negative time, negative 1.50 seconds. So, ano dito yung tamang time? Of course, yung positive, kasi yan yung pagbalik niya doon or pagpunta niya sa point na yon na y is equal to 0. Pero may negative tayo kasi parabola to. So, yung negative na yan, kumbaga, yung pa yung way before pa, bago mag-start yung time na to kung kailan na-release niya itong arrow. Okay? But kasi parabola nga. But for this case, kukunin natin yung time na 7.08 seconds. Okay? And using that time, substitute lang natin yan sa formula for x to get that x na ma-reach no arrow niya pagka-land. And therefore, we know, of course, your v naught, your cosine theta, you will get 532 meters. Okay, so now punta tayo sa acceleration vector problem. Pero bago natin basahin yung problem na to, discuss ko muna yung pinagkaiba or ng components ng isang acceleration vector. Okay? So yung acceleration vector mo, meron niyang parallel component with respect to your v. Meron din niyang perpendicular component with respect to your v or your velocity vector. Yung velocity vector mo naman, ano yan eh, tangent to the path yan eh. Ngayon, for first illustration, so this is the acceleration parallel to v. Kung mapapansin natin, this is aligned or in parallel with your v or with your velocity vector, and this only changes the magnitude of the velocity for this case. Ibig sabihin, yung direction ay same pa rin. Okay, so given this change delta v, yung v sub 2 nito or yung addition nitong dalawa ay sa same direction lang din ng v1 mo. Okay? So that's for the case of acceleration parallel to velocity wherein the speed changes pero the direction ay hindi nagbabago. So yung pangalawa, acceleration perpendicular to your velocity vector, ito yung nagpapa-change ng direction ng velocity vector mo. Okay? Pero in terms of magnitude ng velocity mo, yung speed, hindi nag-change yan dahil sa perpendicular component ng acceleration vector. Okay? So kapag accelerate yung perpendicular component ng acceleration, purely direction lang yung change niya. Ngayon punta tayo sa problem. So we have this skier, si Klee, na ayan, may drawing ako rito. So sabi, Klee, a skier moves along a ski jump ramp as illustrated. So this ramp is straight from A to C, so straight yan, and curve from point C onwards, so as illustrated. So Klee speeds up as she moves downhill from point A dito hanggang sa papunta ng point E where her speed is maximum. So maximum daw yan. So she slows down after passing point E. So this one, pag-pass niya dito, nagsa-slow down na siya. So sabi, draw the direction of the acceleration vector for points B, D, E, F. Okay? So simulan natin sa letter B. For letter B, ang itsura ng acceleration vector ay papunta ron sa same direction, given na nagsispeed up pa itong skier na to at this point. And given na straight line lang to, so purely ano lang to, parallel lang yung component na meron tayo for the acceleration vector relative to your velocity. Okay, so nag-speed up siya dyan sa point B, pero pagdating natin ng point D, ang sabi dito sa problem, pagdating mo ng point D, nag-speed up ka pa rin, pero this time, curve na yan. So may curve ka na, hindi na siya straight line. And therefore, we expect na for your acceleration vector, meron na siyang perpendicular component din. Kasi nagkakaroon ka na ng change in direction for this case. Pero at the same time, nag-speed up ka pa rin at this point. That's why itong angle na to, or I should say, itong vector A na to, acceleration vector, ay nasa unahan nitong normal imaginary line na to. Okay? So at point E, ang sabi, her speed is maximum, and therefore, we can draw here na yung acceleration vector mo ay parallel lang doon sa, or I should say, align doon sa perpendicular na line na broken line na to, which is the imaginary perpendicular line relative to your point E. Ngayon, yung last naman sa point F, given na nag-slow down na yung skier natin, therefore yung acceleration vector na to is behind na netong imaginary perpendicular line na to. So ganun yun for this conceptual problem. Okay, so next we have this simple problem for uniform circular motion. At ito yung problem. So solve natin to. A jet plane flying at 170 meters per second pulls out of a vertical dive by turning upward along a circular path of radius 750 meters. So calculate the acceleration of the plane. So for this problem, i-assume natin na uniform circular motion to, meaning we have this constant speed v along this circular track. At the same time, nag-vary lang yung direction niya kasi nga circular yung motion na to. And therefore, we can use our definition of centripetal acceleration, which is always directed towards the center ng circular motion. Binigyan tayo ng speed dito, which is 170 meters per second. Meron din tayo radius dito na 750 meters. And therefore, this is very easy lang. Substitute mo lang yung values dito. Then you will have your centripetal acceleration, which is equal to 38.5 meters per second squared. Okay? Okay, so next problem is on relative motion. And maraming nalilito rito sa topic na to or sa pag-solve nito. So, simulan natin dito sa very simple muna. So, ether, so that's car A, so drives north on a straight two-lane road as shown here sa drawing ko at a constant 70 kilometers per hour. So, ayan siya yung color green. Then, we have another car. So, this is car B in the other lane approaches you to a constant 100 kilometers per hour. So calculate letter A, the car's B's velocity relative to car A. So parehas kayong gumagalaw. So relative to car A, ano yung velocity ni car B? Then letter B, calculate cars A naman, velocity relative to car B. Okay? So relative sa dalawang gumagalaw na frame of reference na to. So start muna tayo dito sa VBE na to, or this is the velocity of the car B relative to Earth. So we have this equation. This is equal to VBA, the velocity of car B relative to A, which is yung hinahanap natin kaya yellow to, plus yung green, another known quantity. This is the velocity of car A relative to Earth. Okay, so sir, paano nangyari to? So nangyari to, tingnan mo yung fraction. Mas madali sigurong malaman to based sa fraction na to. Makikita natin, this is B over A, this is A over E. So kung i-multiply mo to, sipin mo para magka-cancel lang yung A dito. So you will have your B over E, or the velocity of car B relative to the Earth, and therefore you will have this expression. Pero i-manipulate mo pa to kasi ang gusto natin malaman ay ito, the velocity of car B relative to A. So manipulate mo lang algebra. Then you will have this value for letter A, which is about negative 170 kilometers per hour. Okay, so that's for letter A. Then for letter B, same method lang, but this time we want to find the velocity of car A relative to B. So, isipin mo na parang fraction lang ulit to, magka-cancel si B, then you will have A over E, which is known quantity, alam natin to, relative to Earth lang naman to, velocity of B relative to Earth, and isa lang yung unknown. Therefore, you can calculate V A relative to B, which is positive 170 kilometers per hour. Okay? And that ends this short problem solving video for kinematics. So thank you guys.